Alright, so in this video we're going to just talk about some basic stats. So we're going to start working with data, and it'll be important just to be able to compute a few basic things. And so, um, one way to characterize a numerical data set is with one summary number, and that usually is the sample mean. And so if you have some data, these are scalar values, x1, x2 through xn. Then the sample mean we'll say is x bar, and that'll be defined to be the average, 1 over n times the sum. K equals 1 to n of xi. So that's a scalar as well. Good. So if you have a set of vectors, you can also take the sample or the sample mean of a set of vectors, or sectors, no, set of vectors. So if I have x1 as a vector, x2 as a vector, down to xn as a vector, then the mean is another vector, and the mean vector, this will be kind of a confusing notation, but let's see, what did I use in the notes? I didn't, okay, I didn't use anything special on the notes. I used boldface, but it's hard to do boldface. I'll do an underscore. For the mean, okay. And so that's just going to be the sum of the vectors, right? In linear algebra, we know that we can sum a set of vectors together, and that's exactly what you're doing here. Okay, so this is again a vector in our vectors in Rm, I guess. So this will be vectors in Rm. Good. All right. You could also, if you have a set of matrices, right, that are m by n, and you have k of them or p of them, then you could also take the mean matrix. I guess I didn't identify what they were. A1 through A sub p. You could just make a sum of matrices too, right? Let's see, my index. I haven't used k yet, so that'll be my, oops, not infinity. I've got p of them. Good. And so this is again a matrix, so that's going to be Rm by n, right? Good. All right. So it's interesting to think about a matrix, because a matrix can be thought of as one, a collection of rows, and so we could find the mean over the rows. Right, and so by that I mean the result is a row. Right, so if you have your matrix, right, you would be summing down each dimension so that the result is a row. But of course, you could do the opposite, a collection of columns, in which case you'd find the mean over the column vectors, and the result is a column. So in my graph here, or my diagram, I could, a single matrix I'm given, right? I could also, oh, that's going to be, let me just redraw it down here. So in this case, I'm thinking of summing across, right? And so the result here is going to be a column. So this would be the mean over the columns. That's what I'm talking about. Now I should say that I think there's a command column mean in Python, and that means something different. That's actually going to mean take the mean down the columns, and so you would end up with a row. And so we'll have to be careful about our language for that bit. Okay, then finally, you can think of a matrix is a collection of numbers. And in that case, you could compute the grand mean, what's called the grand mean. The grand mean. And that's just treating the matrix as just a collection of numbers. And so, if your matrix has A11, A12, and so on, down to AMN, algebraically then, you have m times n numbers, and so we would say that the grand mean is 1 over mn times the double sum now. Let's say I equals 1 to n, j equals 1 to m. It depends on how you want to write that, aij. This is just saying sum over all the sum over all matrix elements. Okay? And again, that's called the grand mean. Good. And so, just to talk a little bit about how to compute these in MATLAB or Python or R, well, maybe I'll let you read those. That's on pages 17 and 18. MATLAB, Python, and R commands for computing the means. By the way, I think I'm going to not do as much R in the future. So if you're using R, let me know if you want me to continue with the R code right now. Otherwise, I'll just focus on the MATLAB and Python. There are other ways of computing a middle number, right? For a set of data. Other measures of the middle. Right, we have the mean, we have the median, and we have the mode. We're probably not going to ever use the mode in this class. The median works, the syntax for the median works just as well, or just almost almost exactly the same as the mean in your computer code. So I'll just leave that. The median is the number so that exactly half of the data number so that exactly half of the data is above and half is below. Half of the data is above. Half is below. The nice thing about using the median, by the way, is that the median is not as if you have like a big number, one big number, an outlier, then the mean is very sensitive to that outlier, but the median is not as sensitive to outliers, and so sometimes that can be helpful. Good. Okay, so now I said that a matrix could be thought of as either a set of rows or a set of columns or a set of data, scalar entries. And so when you're working with your data, it's not clear how you should think of it sometimes. In that case, there's a way of mean subtracting your matrix so that it's centered for your data analysis. And so why should we center the data? We're always going to assume our data is centered, and the reason is because, for one thing, you could imagine if your data is all sitting out here, what's going to happen when you're analyzing this data is that the first part of the analysis is that you're going to have to go out here to the mean, and so the mean you don't want to be as part of the data analysis. You want the mean to be 0. So it's a lot better to assume that your data is already grouped around the origin. That'll make the rest of our linear algebra work. It's actually necessary for the linear algebra, not so much for the statistics that we're going to be doing. And so you're going to want to mean subtract the data. Mean subtract your data first. Good. And so let's see how we can do that with a matrix of data. It's actually fairly straightforward. There's just, I should say, at the end, what do we mean by double centering the data? Well, maybe I should pause here for a second. Before we do double centering, in this picture that I've just drawn here, you might imagine that the data is like 100 points in R2, right? And so in that case, you can sorry, I think I'm going to pause the video here. My phone's going off, and I'm at 11 minutes anyway, so we'll pick this up in the next video.